Hi, I'm Bobby Balicki from the National Electrical Manufacturers Association, better known as NEMA. Thanks to the U.S. Department of Energy, we are proud to present Vids for Grids, new media for the energy workforce. In partnership with George Mason University and NEMA members, we've developed a series of short educational videos introducing electrical equipment that's used in the smart grid, the electrical grid for the 21st century. This series is going to present a dozen of the most important products that are critical to a smart grid success. Our mission is simple: to make you more aware of smart grid technologies and help you consider a career in power engineering. This edition of Vids for Grids takes us to Westborough, Massachusetts, where we will visit A123 Systems, who works on grid-scale battery storage, a vital part of the smart grid. Here we are in Westborough, Massachusetts, just outside of Boston, home of A123 Systems, where today we're going to learn about grid-scale battery storage. Let's go take a look.
Today on the grid, when electricity is created, it has to be used instantaneously. So there's no place to store it if there's not enough users and too much production. So it's wasted energy. So batteries allow you to store that energy. So in the case of a solar array, if the cloud goes over and the solar array is not producing electricity, the batteries can provide and make up that electricity for that time frame that the cloud's going over. The main components in a grid storage system are obviously the batteries themselves. So you can start out at the cell, but you have a battery system where you have a cell, some type of holds it, contains it, and then you have a management system for the batteries themselves. You also then have an inverter that converts the DC into AC at the level that it needs to be for the grid. And in some systems, you might have a cooling system, maybe a chiller or some kind of a condenser that would aid the cooling system for the batteries and the inverter systems.
For many, many years, when electricity was produced, it had to be consumed. It wasn't stored, so it was as needed, it was produced. Well, there still has to be a balancing act. So when the load decreases and generation needs to back off, well, there needs to be something in the middle that ramps up and down to balance between production and consumption. Batteries are perfectly suited to do that. Currently, that role is filled by combustion turbines that ramp up and down. The problem there is that they're slow responding and that they produce a lot of emissions. Batteries, on the other hand, can be inserted into that role and respond very, very quickly and be absolutely clean because they're charging and discharging to perform that same role. The power grid is roughly divided up into transmission and distribution. Transmission are the big high voltage power lines that carry electricity great distances. Distribution is when it gets reduced down in voltage and delivered to the homes and to the factories, that very edge of the power grid. A lot of that infrastructure is aging, and also, especially in cities where there's a large population growth, it's stressed. So if you can imagine this, a system that has been designed and improved and worked on for 100 years to have power flow in one direction, now has to deal with power flowing in two directions. Having it introduced at the distribution level, say from rooftop solar units or distributed generation units, small generators that are down in neighborhoods or behind factories. The power now flows in at all levels of the grid as opposed to flowing down from a central point.
I'm here with manufacturing test engineer Matt Mara of A123 Systems, who's here to talk to us a little bit about the manufacturing process. So Matt, walk us through the first steps of this process.
Well, the first step of the manufacturing process here is our battery submodule, where our batteries are welded together and we have a PC board on top that monitors the health and state of the batteries. That's the first step, and when we integrate that together into larger and larger sub-assemblies. We test them individually as modules, we test them as a tray, we test them in a rack, and then we test them finally as a full container.
Okay, now after the testing process, what happens then? Is it ready for shipping, or is there any more?
Well, we do a final test on the entire container, and then that accepts it ready for shipping to the customer.
With the deployment of renewable energies, we also need better technologies to be able to support them. The electric grid as it is today isn't designed to have a large amount of highly variable energy coming into it. You know, the sun isn't always shining, the wind isn't always blowing, so you have to be able to accommodate when the wind does stop or when the sun stops shining. So that's where grid storage is going to be most valuable, is to be able to improve the minute-to-minute quality of the power. At A123 Systems, we take our battery modules and we group them together into IT server racks, and then we gang these together into a shipping container. So I worked with a container manufacturer to design a custom container that would support our needs specifically. At a power plant or at a utility yard, there might be 10 of these containers, and they all need to work in unison when the utility wants them to work. I'm very satisfied with the product that we're able to deliver. You know, I feel good seeing our product leave the door and knowing that I'm hopefully helping to stem climate change or global warming.
Storage in the policy world is sort of a new animal. Over the past 100 years, our grid has remained relatively constant in the types of technologies that it's used. You've had traditional generators, wires, and loads that tended to operate on much the same principles. Storage is new because it allows you to move energy over time, and it requires new policy constructs because our grid rules have been built on the assumption that energy is consumed the minute that it is generated. What we need to do now is create rules that value the ability to move energy from one period to another. One of our vice presidents likes to say that he likes to hire engineers that are Swiss Army knives rather than scalpels. A decision maker is faced with many competing priorities, including the technical merits of the solution an engineer proposes. So it's very important for an engineer to be able to communicate the advantages of a certain solution so that the decision maker can make the best choice in the end.
Today we learned a lot about grid-scale battery storage systems and their importance to the efficiency and reliability of the smart grid. These are systems that operate under a megawatt power range and are crucial for the reliability of smart grid technologies. From Westborough, Massachusetts and A123 Systems, on behalf of NEMA, I'm Bobby Balicki.
Mark 5, 23. Action!